Listen-only mode.
Good afternoon, everyone. Thank you for joining us for today's webinar, Hazmat Series Part 1, Hazardous Materials Placards, brought to you by the Shortline Safety Institute and the American Shortline and Regional Railroad Association. My name is Sabrina Weiss. I'm the Vice President of Education and Business Development for the Association. And before we begin, I want to let everyone know that we're recording this webinar and we will make the recording available to participants for a limited time, so you may go back and review anything discussed today. To ensure quality audio for the recording, all attendees are on mute and you will only be able to hear our presenters speaking. However, if you have questions during the presentation, you may type them into the questions bar on your screen and we will read through all the submitted questions at the end of the webinar. I want to thank today's presenters, Michele Malski, Safety Programs Manager for the Shortline Safety Institute, and Michael Long, Senior Safety and Operations Manager for the Shortline Safety Institute. Both Michele and Mike are on the line and here with me now, so I will turn it over to Michele to get us started.
Thank you, Sabrina, for that introduction. Welcome to the very first Hazmat Series webinar. Today we will be focusing on the introduction of placards, their classification and subdivisions, as well as the basic federal reporting requirements. Mike Long and I will be hosting you this afternoon, and so if you have any comments or questions about this webinar or our safety culture assessments, please feel free to ask us at the end of this presentation during the Q&A portion. Let's begin. Before we get into the placard classifications, we need to understand what a hazardous material is. By its federal regulation definition, a hazardous material is a substance or material capable of posing an unreasonable risk to health, safety, and property when transported in commerce, and has been designated as hazardous under Section 1503 of Federal Hazardous Materials Transportation Law. This term includes hazardous substances, hazardous wastes, marine pollutants, elevated temperature materials, and other materials designated as a hazardous material in 49 CFR or Code of Federal Regulation 172. So now that we know what a hazardous material is, where does this placard system come from? The Hazardous Materials Regulation, also referred to as the HMR, which would be 49 CFR parts 171 to 180, specify requirements for the safe transportation of hazardous materials in commerce by railcar, aircraft, vessel, and motor vehicles. So who does this apply to? Each person who performs or causes to be performed functions related to the transportation of hazardous materials, such as determination of and with compliance, basic conditions for offering, filling packages, marking and labeling packages, preparing shipping papers, handling, loading, securing, and segregating packages within a transport vehicle, freight container, or cargo hold, and transporting hazardous materials. So basically, if you have a hand in any of these aspects, all the way from the loading to the transportation to the packaging of it, this regulation applies to you. In general, the HMR prescribes requirements for classification, packaging, hazard communication, incident reporting, handling, and transportation of hazardous materials. Today we will only touch on a few of these topics, but stay tuned for future webinars coming soon covering these other aspects of the HMR. Okay, so we have this HMR. So who enforces it in the transportation world? The HMR are enforced by RSPA and DOT's modal administrations. The FAA, the Federal Aviation Administration, the Federal Highway Administration, the Federal Railroad Administration, the FRA, and the United States Coast Guard. So now what happens if you violate this regulation? Federal law provides for civil penalties of not more than $25,000 and not less than $250 for each violation. An individual who willfully violates a provision of the HMR may be fined up to $250,000, be imprisoned for more than 5 years, or both, and a business entity may be fined up to $500,000. The HMR has procedures and criteria for determining the hazard class and the proper shipping name. Some materials are so hazardous that they are specifically designated as forbidden in the hazardous materials table in section 172.101 in the CFR. There are many of these materials that may not be offered for transportation or transported in commerce. Some even require special review and approval. Others are designated as forbidden from transportation by specific modes such as air. So now, what are placards? A placard is then a way to identify the class and division of a hazardous material. Now, what's the difference between a class and then a division? Well, the class is the classification, the grouping for the particular materials. This is kind of the overarching family. Then the subdivisions or the divisions of the classification are the particulars of that family of materials, most commonly referred to as their subdivisions. If you look on the slide in front of us, you will also be able to click on this link later to give you right to the placarding guide from the DOT. Take a look at each of these placards on your screen. Familiarize yourself with each. Even if your railroad doesn't transport these, your neighboring interchange partners just may. It is important to be familiar with these images. Notice that there are different images, numbers, and colors for each placard. Let's take a closer look at these placards. Let's look at the first class. The placards for all of the Class 1 explosives are an orangey yellow in appearance, and it has the Class 1 number on it in the lower quadrant of the diamond-shaped placard. It also has a subdivision, such as 1.4 or 1.5. A UN number may also be displayed in this location. We can clearly see that all of the explosive placards look similarly, as they are all from the same class. Now let's talk about these materials. Classification 1, explosives. Explosives are any substance or article, including a device, which is designated to function by explosion or which, by chemical reaction within itself, is able to function in a similar manner, even if not designed to function by explosion. The explosive group has 6 subdivisions. We will start with 1.1. 1.1 is the top of the food chain, so to speak. These are explosives with mass explosion. Within this group, you're going to find examples which are not so easy to pronounce, so bear with me. You're going to have things such as rocket motors, warheads. Okay, now those were the easy ones. Now trinitrotoluene, or more commonly and much easier to say, TNT, NTO, or nitrotrilazone. On the topic of TNT, here's a quick brain teaser for the audience. Think about this. Think about Wile E. Coyote. Is TNT the same as dynamite? Well, if you thought no, they are not, then you would be correct. Although they are both explosives, there are very few similarities between the two. So somebody better call AC/DC because they got it wrong. You can't say I'm TNT and I'm dynamite because they are not analogous, and they're not the same. TNT is a yellow compound from a chemical name, as we mentioned before, trinitrotoluene. Bear with me. TNT is a lot harder to detonate and can be melted down into hard shell casings for other industrial uses. Dynamite, on the other hand, also created by Alfred Nobel, which name should sound pretty familiar to some, is a white powder and is more powerful but is a lot less stable than TNT. Fun fact that it was actually marketed as Nobel's safety blasting powder, which later became gunpowder. And this degrades over time, which means that these materials become less and less stable. Dynamite is still used in mining and construction processes. Now that we took a little brief sidebar, let's come back to the classifications. 1.2, explosives with blast and projection hazards. Within this group, you will find examples such as cartridges, mines with bursting charge, igniters, bombs with bursting. 1.3, explosives with minor blast hazards. Within this group, you will find examples such as propellants and flash powder. 1.4, explosives with major fire hazards. These will be detonators for ammunition, cartridges, fireworks, fusees, and distress signals for ships. 1.5 blasting agents. These are substances that are very explosive and very insensitive. An example would be ammonium nitrate fuel, a mixture containing only prilled ammonium nitrate and fuel oil. 1.6 EEI, or explosive extremely insensitive articles. Extremely insensitive articles do not have a mass explosion hazard. Also within the explosive classification are forbidden explosives. These cannot be offered for transportation or even transported. Let's take a look at the next class. Classification 2, gases. This group has 3 subdivisions. 2.1, flammable gases, gases that can ignite on contact with an ignition source. Within this group, you will find examples such as many refrigerant gases, aerosols, natural gas, propane, and hydrogen. 2.2, non-flammable gases are non-toxic. Gases which are neither flammable or poisonous. Examples would be compressed air, compressed argon, liquefied gas, refrigerant gases, and neon. 2.3, toxic gases, liable to cause death or serious injury to human health if inhaled. Some examples of this would be ammonia solution, chlorine, insecticides, anhydrous hydrogen, and iodide. Now take a peek at 2 things on this slide. First, please make note that the asterisks listed above indicate that the word toxic is synonymous with poisonous or poison. Second, let's take a peek at these pictures. The red placard is attached to one side of a tank car. It is in group 2, gases, it's flammable, and the ID is 10275. This commodity is non-odorized liquefied petroleum gas. Placards give you a quick and easy way to identify hazardous material, which is why it is so important to keep your placards to inspection code. This placard was in subdivision 2.1. The second picture with the white placard is 1017. This is also a gas, but it is chlorine. The subdivision here would be 2.3, as it is a toxic gas. Let's move to the next class. Classification 3, flammable liquids and combustible liquids. A flammable liquid is defined as such: a liquid having a flash point of not more than 60.5 degrees Celsius or 141 degrees Celsius, or any material in a liquid phase with a flash point at or above 37.8 degrees Celsius and 100 degrees Fahrenheit, that is intentionally heated or offered for transportation or transported at or above its flash point in a bulk packaging. There are some exceptions. Combustible liquids. A combustible liquid means any liquid that does not meet the definition of any other hazard class specified in this subchapter and has a flash point of above 60.5 degrees Celsius or 141 degrees Fahrenheit and below 93 degrees Celsius and 200 degrees Fahrenheit. Examples of these would be the alcoholic beverages, adhesives containing a flammable liquid, diesel fuels, shale oil, kerosene, liquid wood preserves. So what is a flash point then? Well, I'm glad you asked. A flash point, per definition, has 49 CFR 173.120. The flash point means that it is a minimum temperature at which a liquid gives off vapor within a test vessel in sufficient concentration to form an ignitable mixture with air near the surface of the liquid. It shall be determined with the standard methods test on different scales for different materials. Classification 4, flammable solids, spontaneously combustible materials, and dangerous when wet, water-reactive substances. 4.1, flammable solids, solid substances that are easily ignited and readily combustible. Examples of these would be magnesium or sulfur when it's molten. 4.2, spontaneously combustible material. This could mean 2 things. It's either a pyrophoric material, and that means a liquid or solid that, even in a small quantity, and without an external ignition source can ignite within 5 minutes after coming in contact with air when tested. Or it could be a self-heating material, and that is a material when in contact with air and without an energy supply is liable to self-heat. Some examples of these would be fish meal, unstabilized fish scrap, various metal shavings, oily rags, wet cotton. 4.3, dangerous when wet material. This is a material that, by contact with water, is liable to become spontaneously flammable or give off flammable or toxic gas at a rate greater than 1 liter per kilogram of the material per hour when tested. Examples of this would be alkaline, earth metal alloys, sodium, and zinc ashes. Now let's take a quick minute and look at the specific hazards of one of these materials. Let's pick oily cotton waste. That would be an example of 4.2 subgroup. The solid material itself can be many different colors, but it would be saturated with oil, whether that's grease, a preservative oil, or just regular oil. This material is highly flammable. This material may ignite upon exposure to air. It can react with water to produce a flammable gas. It may be ignited by friction, heat, sparks, or flames. Some may burn rapidly with flare burning effect. Now, how did I know that? Well, I turned to my most recent emergency response guidebook for 2016, and I looked up what cotton waste oily would be. In this slide, we're going to look at the 2016 Emergency Response Guide booklet. Under this guide are all of the hazardous commodities that we're talking about today. This is just a snapshot of how this guide would help you understand the potential hazards, public safety, and the emergency response plan for this material. As you can see, it discusses many different areas of response. Not only the protective clothing that people need to wear when handling this, but also what to do in the case of an evacuation. Things that are important here to notice is that this could burn your skin. So we have to make sure that our crews understand the health and hazards of each one of the hazardous materials that they are transporting each and every day, so they know not to touch certain things if there was ever an emergency. And isn't it interesting in this example that you need scuba gear? That does not mean to go down into the barrier reef and look for really cool sea creatures. In fact, it's actually a breathing device that when there's any sort of area in which there is not enough oxygen being produced, you need to wear this so that you would be able to get into that area. This also requires special training. On the other side of this guide, you will see the first aid. It's going to tell you who to contact. Now that we took a brief sidebar with this commodity, let's get right back into our classifications. Classification 5 is oxidizing substances and organic peroxides. 5.1, an oxidizing agent other than organic peroxides. This would be ammonium nitrate or hydrogen peroxide. Oxidizing materials are liquids or solids that readily give off oxygen or other oxidizing substances. They also include materials that react chemically to oxidize combustible or burnable materials. This means that oxygen combines chemically with that other material in a way that increases the chance of a fire and explosion. This reaction may be spontaneous at either room temperature or may occur under slight heating. Oxidizing liquids and solids can cause a severe fire and explosion hazard. Organic peroxides, either in liquid or solid form. Organic peroxides can be severe fire and explosion hazards as well, and some may be toxic or corrosive. Depending on the material and the exposure, meaning the inhalation, the eye or skin contact, or even if you swallow it, and the dose, or the amount of the exposure, this could really cause some harm to the body. Corrosive organic peroxides can even attack and destroy certain metals. You're going to see organic peroxides in the plastics and rubber industries, manufacturing process for polyester and acrylic resin. All right, we're on classification 6. Classification 6 is toxic substances and infectious substances. Above, again, you're going to see those asterisks. Toxic is also synonymous with the word poison, so just remember that. 6.1 breaks into A and B. So 6.1a is toxic substances that are liable to cause death or serious injury to human health if inhaled, swallowed, or by skin absorption. This would be your potassium cyanide or mercuric chloride. 6.1b, toxic substances which are harmful to human health. This is going to be your pesticides and some forms of your chlorides. 6.2, your biohazardous substances. And this breaks down into 2 categories as well. There's category A, which is the infectious side, and there's category B, which are samples. And samples would be virus cultures, pathology specimens, and intravenous needles. Now take a peek at the picture that I have on this slide. It's going to be kind of tricky because we saw a very similar image with the classification 2. Is this the same, or is this a different commodity than what we saw for the gases? Well, this is not in classification 6. In fact, this is a class 2 gas. You're going to notice that on both of these examples, these pictures, there's skulls in each one of those classifications. Although there are similar imagery on some of these placards, it is vital for you to be able to clearly recognize how each placard looks and how important it is for you to be familiar with the differences so that you know how to respond. Classification 7, radioactive materials. Radioactive substances comprise substances or a combination of substances which emit ionizing radiation. This will be your uranium or your plutonium. Classification 8, corrosive substances. Corrosive substances are substances that can dissolve organic tissue or severely corrode certain metals. There's 8.1, which are your acids. That's going to be your sulfuric acid, hydrochloric acid, and your 8.2, which is your alkalis. That will be your potassium hydroxides and your sodium hydroxides. Here again we have a picture on the slide, and that's 1824. That commodity is sodium hydroxide solution or caustic soda solution. You'll most commonly see this transported in a train car as well. But again, you can see the classification imagery remain the same. You have the classification in the lower quadrant of the diamond, and you'll have similar imagery on the top part for the corrosive material. Lastly, we'll wrap it up here with classification 9. This is your miscellaneous category. It's going to have your miscellaneous hazards, materials, products, substances, or organisms. Hazards that do not fall into the other categories, such as asbestos, airbag inflators, self-inflating life rafts, dry ice, those would all fall under here. Class 9 is the last classification. In lieu of the Olympic spirit, I will now pass the torch over to Mike Long and his expertise on the federal regulation introduction and overview for reporting.
Okay, thanks, Michelle. Part of, Michelle has given us an overview of the requirements for the placarding and what they need to look like, but what do we need to do on the ground? So again, the first thing we do, refer back to the CFR, the Code of Federal Regulations. Now, worst case scenario, you have an accident with a release of certain hazardous materials. What do you need to do? First thing is immediately, or to quote the regulation, as soon as practical, but no later than 12 hours, you need to report the spill or the release of the hazardous materials by telephone to the National Response Center, commonly known as the NRC. The report must include the following information: the name of the reporter, name and address of the person represented, phone number, date, time, location, the extent of any injuries, the class or the division, the shipping name, the quantity of the hazmat involved, and the type of the incident and the nature of the hazardous material involvement, and if there's continuing danger to life at the scene. Now, this is only the federal regulation calling into the National Response Center. There are many states that have their own reporting requirements, which you need to be familiar with if you operate in those states. Inspection of placards. When you have a rail car that contains hazardous material, must be placarded. But some of the requirements for the placards: they must be consistent with the shipping paper information, i.e. the hazardous material, the waybill list that the crews have. The placards must meet that. They must be on both sides and both ends of the shipment. They must be in the placard holders or securely attached to the rail car, the trailer, or the container. They cannot be damaged or faded. The color should be similar to the color printed in this document, which you saw earlier. Also, they cannot be obscured by dirt, dust, or any part of the car. They must be clearly visible. Oriented horizontally, readily visible from any direction they face. Now, when you're picking up a hazardous material shipment at a customer's facility or siding, and if a placard is not correct or does not meet the standards above, immediately notify the customer, the train dispatcher, your yardmaster, or your supervisor as appropriate. Do not accept that hazardous material shipment until the corrections have been made. And if a placard does not meet the standards above or is discovered missing en route, again, notify your dispatcher, yardmaster, or your supervisor. It is their responsibility to arrange and correct the problem at the next forward inspection point. If you're on the ground and you're inspecting trains or inspecting your cars, what's some of the items you need to do? Again, we talked about the first one. The placards on the car must match the shipping papers on both sides and both ends, and all the placards should match on all four corners of the car. They must be in the placard holders and securely attached to the rail car, the trailer, or the container. They cannot be obscured by any part of the car. Here are a couple of examples of faded placards. The one on the left, the white placard, you can clearly see is faded and part of it is missing and damaged. The one on the right, the red placard, the 1987, again, it's faded, part of it torn, and it is obscured where it seems to be folded down. Here's something we all have to be very well aware of: the potential fines and violations for improper placards. It's the railroad's responsibility, both management and the train crews, to ensure the placards and the markings are in place and legible in the event of a leak, a spill, or derailment. It's every railroad's employee's responsibility to be in compliance with the Hazmat regulation. And if you're not, what are the consequences? Every placard, not every car, but every placard that is incorrect can be assessed a fine and a violation of up to $1,000 per placard. So if you have four corners on the car and they're all missing or damaged, that could be $4,000 violation per car. And at this point, I will turn it back over to Michele.
Thanks, Mike. Well, that will conclude today's presentation about hazardous materials and our very first one for this series. If you have any questions about this webinar or our safety culture assessment process, please give Mike Long or myself an email or a call. We'd love to talk to you about it.
Okay, and I'll step in here really quickly, and we have some time for Q&A for folks. So I'll just remind folks that you can type questions into the questions bar on your screen, and we will read those out and go over them before we wrap up. I'll let Michele go over this last slide really quickly, though.
Before we jump into our Q&A, just a reminder for the next webinar, Hazmat Series Part 2. It's going to be the introduction of crude oil transportation. We're going to talk about tank cars. We're going to talk about their inspection. We're going to talk about train placement. We're also going to talk about suspicious devices that you can look out for when you are doing an inspection for one of these tank cars. Mr. Gellner from the ASRA will be joining us for that. That'll be at the end of this month, August 30th at 2 p.m. You better sign up early because there's not a lot of space left. One point I do want to make here, if you've missed any of our previous webinars, please come to our website or click the link below, and it will take you to the past recordings of the other presentations. At this time, we will begin our Q&A session from this presentation.
Excellent. So the first question we have here is, where should you keep placards? Excuse me.
That's a great question. And the answer, short and sweet, is they should be in a readily convenient area. Suggestion might be somewhere near a crew room, an entry or an exit way of any office, somewhere near a rail yard where people walk by every day. So it's a very easy and accessible place to just pick them up and have them and replace them right then and there when you see them. I know in Minot, North Dakota, one of the places I hailed from, there was a whole wall, a rainbow, if you will, of placards. It was very easy to maintain the code for the inspections if we ever saw anything faded. And that does include storage cars, folks. So make sure if you do have any storage cars that you're checking those placards as well. They have to be up to code when they do get transported at some point.
Okay, great. The next question we have here is, if a train is leaving a yard and a placard is damaged, what should we do? Or what would you do? Mike, do you want to take that one?
Yeah, and we touched on that earlier. If you observe any damaged placards or missing placards, first off, the first responsibility is to notify your dispatcher, your yard master, or your supervisor. As it says, the placards must be accurate prior to leaving a yard, or if you're picking up at an industry, you have to have the accurate placards. So always contact your supervisor or the supervisor and comply with their instructions.
Great. Okay, one other question we have here is, where can we get the book that Michele was referring to?
I'm so glad you asked that. Again, I'm going to direct you back to our website. You can go under our resources tab, and you will be able to get the latest and greatest of the Emergency Response Guidebook for 2016. Now, I'm going to warn you, it's in color and it's 400 pages long, so make sure you have the proper settings on your printer for that, but I'm pretty sure you're going to want the color to see all the placard colors and such. But it is available on our website, and if you have any further questions about that, please reach out. We'll also be doing a webinar about how to use that Emergency Response Guidebook in the near future, so keep an eye out for that as well.
So just to clarify then, that's available as a download from the Safety Institute website?
That is correct.
Okay, perfect. It looks like those are all of our questions for today. So unless Mike or Michele have anything else to add to this, I'll give you a moment.
No, thank you very much for joining us again for this very first Hazmat webinar, and we look forward to seeing you guys again.
Okay, excellent. Thank you everyone for joining us today. As Michele already said, this last slide here has contact information for both Mike and Michele on it. So if you have any follow-up questions for them, please feel free to reach out to them directly. Thank you all for joining us for today's webinar, and we'll see you on August 30th for the next one.